So I guess the current experiments that exist, the telescope array and Piaget observatory, I think in the next decade or so, they can probably answer what is the composition of cosmic rays above 10 to the 19 electron volts. Going further than that, looking for sources of alternating cosmic rays, especially above the spectral suppression, is going to be very difficult, just given the small size, relatively small size of the detectors.
Yeah, so actually I don't think that the current experiments as they are built, they could actually measure the composition at really highest energies. So I'm speaking about 50 eV, because you expect in the next 10 years around maybe 100 events at these energies, if you have a surface detector. Fluorescence detector, I think it's a factor of 10 less, so you're going to have like 10 events maybe, if you're lucky. So it's going to be really hard to answer with the current detectors which is the composition exactly in the anisotropy region. So where you expect the anisotropy. So, but maybe upgrades or something that to enhance the detectors could help. Depends on.
And Martina? I can maybe add to the fluorescence technique that it has several limitations, and even with the upgrades it's very difficult to go to much better efficiency. And it's always increasing the statistics on the cost of the performance. So the question is to decide if the quality of the data with the higher statistics is sufficient to accept it.
So I think we need a much larger ground array, something that's at least 10 times larger than Auger, and also it has to have the ability to distinguish between electrons and muons in the air showers. I really don't see any other technique is going to be feasible in the near future.
Do you agree?
So yeah, I more or less agree, but I have a question. Is that I think the first question that we have to answer is like, can we build something that we can actually answer this question? So I'm not sure that so I think in the next 10 years or so we are going to answer some questions like, do we have protons? Because if we have heavy elements, I'm not sure what we are going to do with them. There are these simple questions that one has to answer before thinking of building a 30 square kilometers array or go with high quality space detectors or things like that. So that's why I think is that next year, so enhancements of the telescope array or Piaget observatory could answer some of these basic questions. So is it worth to build another experiment, or we can just say that because in principle it could, in the next years, I think we could answer some simple questions like, is the flux suppression caused by acceleration, or is it caused like source? Is the maximum energy the source, or it's just propagation? So these kind of simple questions, they're not simple because people are trying since hundreds of years to answer these questions, but like what causes the spectral features could be answered or things like that, but to go to the like really sources and find sources, it's going to be really hard.
Okay. And Martina, would you like to add anything to that?
I would like to add that we should not give up looking for a new technique which would have better capabilities than the techniques we have now. So there was a nice try on the gigahertz emission of the showers, which did not work out, it seems. But we should not give up and try to look for something like that, because the current techniques have been here for a long time. We should think of something new and different.